I'll be reviewing the documentation on the NATO shipping website to provide a brief overview of AIS. The Automatic Identification System, or AIS, is a short-range coastal tracking system currently used on ships. The AIS is a digital positional awareness system operating in the very high-frequency maritime band. Its purpose is to help identify ships, to assist in target tracking, search and rescue operations, and to simplify information exchange and provide additional information to assist situational awareness. AIS does this by continuously transmitting a vessel's identity, position, speed, and course along with other relevant information to all other AIS-equipped vessels within range. Combined with a shore station, this system also offers port authorities and maritime safety bodies the ability to manage maritime traffic and reduce the hazards of maritime navigation. The range of reception can be variable and is dependent on factors including signal propagation conditions, sea state, the height of the transmitting and receiving antenna, and the strength of the vessel transmitter. Reception could be as little as 20 nautical miles or as much as 350 nautical miles for powerful transmissions during appropriate atmospheric conditions. The average distance or range is around 40 nautical miles, and with Class B transponders it has much lower or smaller range of up to about 10 nautical miles. AIS works by taking your position and movements via the vessel's GPS system or an internal sensor built into the AIS unit. That information is then collated along with programmable information from the AIS unit, for example Maritime Mobile Service Identity or the MMSI number, the vessel's name, destination and cargo type, and is then transmitted in the background at regular intervals whilst also receiving other vessels' AIS information. The AIS unit can have its own separate antenna, or an antenna splitter can be used from the antenna the VHF radio transmits from. If an antenna splitter is used, it must be an active splitter suitable for a VHF radio and AIS transponder. The International Convention for Safety of Life at Sea, or SOLAS, is an international maritime treaty that sets the minimum safety standards in the construction, the equipment and operation of merchant ships. There are two classes of AIS. Class A is mandated for all vessels 300 tons and above which are engaged in international voyages, as well as all passenger ships. And then there is Class B, which provides limited functionality and is intended for non-SOLAS vessels, and it's primarily used for vessels such as pleasure crafts. AIS operates on two dedicated frequencies or VHF channels, channel 1 and channel 2. So the difference between these two channels are load balancing, so both channels are used to manage traffic efficiently. AIS equipped vessels dynamically switch between these two channels to prevent congestion. This ensures that the AIS messages are transmitted reliably even in areas with high vessel density. And redundancy. The dual channel setup provides redundancy. If one channel becomes overloaded or experiences interference, the other can still transmit and receive AIS data. And then finally, broadcast coordination. AIS transponders use a time division multiple access protocol where each ship is assigned specific time slots on both channels. This coordinated usage minimizes collisions or overlaps transmissions. There are two main types of data that are transmitted. The first is static information, which is transmitted every 6 minutes and also on request. And this data contains, or this information contains, the MMSI number, the IOM number, the vessel's name and call sign, length and beam, type of ship, and the location of the fixing of the antenna. And then the second type of data is dynamic information, and this is the most important because it It contains the information of the exact position of the vessel at that moment in time. It contains the ship's position with accuracy indication, the position timestamp, and course over ground. Concerning maritime security, AIS enables authorities to identify specific vessels and their activity within or near a nation's exclusive economic zone. So when AIS data is fused with existing radar systems, authorities are able to differentiate between vessels more easily. The AIS data can be automatically processed to create normalized activity patterns for individual vessels, which when breached create an alert and highlights the potential threats for more efficient use of security assets. So AIS improves the maritime domain awareness and allows for heightened security and control. AIS shouldn't be switched off except for a few exceptions. So according to the International Maritime Organization guidelines, AIS should always be in operation when ships are underway or at anchor. A ship's crew can in certain circumstances turn off the AIS broadcast for a variety of legitimate reasons, but this behavior may indicate that a vessel is hiding its location and identity to conceal illegal activities. Note that vessels equipped with Class B AIS equipment are not legally obliged to have the equipment turned on at all times. So having a look at the navigation center of the United States Coast Guard, we can have a look at an example of the information that is provided by a AIS transponder. So here we see an example of what vessels' positions may look like on a plotter, and we see on the left a number of orange triangles which represent a vessel. So these are the position of these vessels in real time as depicted in the data transmitted by their AIS transponders. So on the left we will see the data that is displayed on your screen when selecting a particular vessel's icon. So it provides the name of the vessel, in this case Texan, its MMSI number, its call sign, its latitude and longitude, the range, in this case 2.542 nautical miles, its bearing, its course over ground, speed over ground, its navigation status, underway using an engine, its destination, the length of the vessel, the beam of the vessel, the type of ship or vessel, whether it has hazardous cargo, and the time since the last update, and the vessel's draft and ETA. Having a look at the Vessel Finder website, we see the position of global maritime traffic. So these positions are obtained from the vessel's transmitted information, which is picked up by satellite, plotted on the map as we see it here. If you had an account with Vessel Finder and you clicked on one of the vessel icons, you'll get more information about that vessel. I hope you found this short video helpful. Feel free to let me know in the comments if you'd like to see a more in-depth version.